Hello class, welcome to our second lesson dealing with section 7.4. Again, we're dealing with quadrilaterals, which remember are four-sided objects. We're going to go through an example problem dealing with some similar triangles, and then we'll get right back to our quadrilaterals for today. For today's warm-up activity, what I want you to focus in on is just finding the decimal or the fraction for these answers. Now, we did some of these styles of question with similar triangles earlier in our lessons. Most of those questions worked out very nicely because when you cross multiplied and divided, excuse me, they didn't keep going on and on because they divided into each other in a nice fashion. This question, that's not the case. So what you'll notice here is the 16 and 7 go together, and that's not a very good relationship between the two, which means we're going to get some weird answers probably as we go through this situation that may not be as clean as what we're used to, but that doesn't change the fact of how things are set up. So 16 over 7, big triangle to small triangle, so that's the 16 over 7 here, equals 9 over x, because 9 is the long side and then x is the short side, and that would be 9 over x. And then I just cross multiply it, so 16 times x equals 9 times 7, then divide by 16. It's not a never-ending decimal here, because all fractions can eventually end or repeat, but it's still not as clean as what we're used to. Okay, what we need to start noticing is we need to be more comfortable with trusting ourselves in terms of cross-multiplying and how to set things up as we're looking at some of these situations. So that's one thing that you want to think about when it comes to a question like this one. To solve for y, I'll use the same 16 over 7. I don't want to use 9 and whatever I found for x because in the case that it is rounded, I want to make sure I'm exact in my answer. So we're going to use the 16 and 6 again. And then equals 13 over y. I cross multiply, 16 times y equals 13 times 7. And then divide by 16 on both sides and get the number 5.6875. Okay, so just keep in mind that as you keep moving forward in these types of situations, okay, that you won't get integer answers all the time. You won't get, decimals that go to the nearest tenth every time. It kind of depends on the situation, and teachers are going to be more likely to give you numbers that don't work out as nicely. The next thing to discuss is just dealing with the angles of a quadrilateral. Now, these are the base case scenarios. We're going to work a little bit more, in the next class with more complicated versions of solving for x, kind of like what we did for triangles. But remember that a quadrilateral adds up to, the angles add up to 360 degrees. If you're not convinced by that, all you have to really do is take a quadrilateral and cut it from one vertex to its diagonal vertex, and you'll get two triangles. That's why it ends up being 360 degrees. You need to be comfortable about solving equations and setting them up. So for this question, I would say, well, 70 plus 75 plus 115 plus x equals 360. I think everyone's suggestion probably would be to combine the three things that you know, and that's 260 and subtract it to the other side, so x is 100. The second one is the exact same idea. You're going to add the three angles up that you know, okay, which is 280, subtract it from 360, and you should get 80. Now, I'm not saying your work has to look identical to what's shown here, okay, every time, but you want to work towards these two-step equation approaches, okay, or that type of scenario. Because what's going to happen here is instead of x, it might be 3x plus 7. Or there might be an x here and a 5x here, and you still have to combine like terms and solve. And we'll look more of that in our next lesson. But we want to make sure, that we're comfortable solving that situation in order to figure out what the value for x is. So triangles add to 180, quadrilaterals, no matter what type of quadrilateral, adds up to 360. And if that's difficult for you to kind of remember, just think of a square. It has four right angles. Each angle is 90 degrees, so that makes it 90 times 4, which is 360. Okay, the next questions are drawing questions. Because you have lined paper, this ends up being a little bit easier than maybe what it would be in other cases. This says draw a parallelogram with a 50-degree angle and a 130-degree angle. What I would suggest here is you just draw a horizontal line segment, draw 50 degrees from one of them and 130 from another, and then just draw those lines and go so far. So let's say you draw this one 3 inches, make that one go 3 inches, and then just cut them off, and then that would be your other parallel line to the horizontal. Because most of you have lined paper, you could always use that to your advantage. One key aspect of parallelograms that's nice is that the opposite angles, okay, these catty-corner angles that are kind of facing each other are going to be the same or congruent. Okay, so if this angle is 130, the one opposite is also 130. If this one's 50, the one opposite is 150. And what you'll notice is that these two add up to 180. That's another property of parallelograms that you'll learn in geometry. Okay, we're just kind of scratching the surface on some of those things. So when you draw a parallelogram, draw the two angles and then extend them so far, and then you can cut off the top and make sure you have the right distance for each of those side lengths in order to make the parallelogram. The next one says draw a right trapezoid with parallel sides of 3 and 5 centimeters. So a right trapezoid means there's a right angle in it. So this is a different looking trapezoid than what we normally draw. We normally draw what's known as the isosceles trapezoid that we talked about the other day, where the two sides kind of slant in and there's the longer side and the shorter side. But there could also be what's known as a right trapezoid, because the definition of a trapezoid is just one pair of parallel sides. So a right trapezoid will have a right angle. Well, if this one has to be a right angle, so will this one if these two lines are parallel. Notice I put the arrow to show that I meant that they're parallel. I'm just going to put a dot somewhere, measure 5 centimeters, and notice it doesn't matter how far apart they are. There's no stipulation on that. So you could have a very skinny rectangle, or a trapezoid, excuse me, or a larger one. Okay, the width doesn't necessarily matter. And so all that this stipulation was just make this a right angle, draw straight up from there, and then over 3 centimeters and connect. There should be this type of situation on all of our pictures, no matter how wide we made the trapezoid. But again, there's no stipulation on any of those situations in order to find that. Okay, your homework today has a lot of different styles of questions. It's numbers 10 through 26 in section 7.4. One thing that you want to pay close attention to is kind of those always, sometimes, never types of situations. So like, for example, is a square a rectangle versus is a rectangle a square, and it's always, sometimes, or never. Okay, those types of situations are going to show up again. So you want to make sure that you're looking at the definitions closely so that you understand how to find those answers. Have a good day, everyone.